Welcome to the DIY Honda Garage channel. The diagnostic trouble code P0777 indicates an issue with the continuously variable transmission, CVT, of the Honda Civic, particularly the driven pulley pressure control solenoid valve. This component is crucial for regulating pressure within the CVT system, which directly influences the pulley ratio, allowing the vehicle to change gears seamlessly. If the solenoid valve becomes stuck in the on position, it can cause improper belt engagement, leading to abnormal driving characteristics. This may result in a situation where the vehicle experiences overdrive pulley ratio even when stationary, indicating a malfunction. Understanding the role of the CVT and the components involved is key to troubleshooting and rectifying this issue effectively. This guide will detail the error, possible causes, symptoms, and steps for troubleshooting this specific trouble code to restore proper functionality to the CVT system. The DTC P0777 indicates a problem with the continuously variable transmission system of the Honda Civic, primarily involving the driven pulley pressure control solenoid valve. This solenoid valve is integrated with the valve body assembly, and its primary role is to manage hydraulic pressure that operates the driving pulley within the CVT. When excessively engaged, the solenoid may cause the pulley ratio to misbehave, particularly when the vehicle is stationary yet showing signs of overdrive operation. This anomaly may lead to belt slippage during acceleration, which compromises vehicle performance and can be potentially damaging if not addressed. Being aware of the solenoid's precise location and function helps in diagnosing the issue accurately and efficiently. There are several potential causes for the DTC P0777, starting with the solenoid valve being stuck in the on position. This can occur due to wear, mechanical failure, or corrosion affecting the solenoid's functionality. Additionally, electrical issues, such as poor connections or short circuits in the wiring leading to the solenoid, may also contribute to this fault. Another common cause to consider is fluid contamination. Dirty or inadequate transmission fluid can lead to ineffective hydraulic pressure regulation within the CVT system. All these factors combine to create circumstances that enable the DTC to trigger, indicating a malfunction that needs addressing to restore proper operation of the transmission system. The symptoms associated with DTC P0777 are critical to identifying the malfunction in the CVT system. Drivers may experience belt slippage, which is a noticeable loss of power transfer during acceleration. This can be felt as a lack of responsiveness when the throttle is engaged. Poor acceleration may also be evident, which can lead to frustrating driving experiences, especially when merging onto highways or climbing inclines. Inconsistent gear changes can manifest, with the vehicle seeming to struggle to determine the correct driving mode to engage effectively. These symptoms, when aggregated, point towards the underlying issue with the driven pulley pressure control solenoid valve being stuck or malfunctioning within the system. The first step in troubleshooting the DTC P0777 is to ensure that the engine is started and idling smoothly. This foundational step is crucial as the engine's operation will directly affect the CVT's performance. You should check for any abnormal noises or vibrations while the engine is idling, as these could indicate additional issues that may complicate the diagnosis. Once confirmed that the engine is running without issues, it sets the stage for further assessment of the transmission system and the associated solenoid valve. A smoothly running engine signifies that the primary systems are operational, allowing you to focus on the CVT functionality accurately. Next, take the vehicle for a test drive, accelerating in the D drive position until the vehicle reaches a speed of 37 miles per hour, or approximately 60 kilometers per hour. During this phase, observe how the vehicle behaves, paying attention to any slipping or unusual sensations indicative of poor transmission engagement. This test drive will simulate normal driving conditions and will help validate whether the issue is present during typical operational speeds. It's critical to note any signs of slipping or abnormal power transfer that might occur during the acceleration phase, as this data will inform subsequent troubleshooting steps and confirm the failure of the solenoid valve functionality. After accelerating to 37 miles per hour and gathering observations, the next step involves slowing down and stopping the vehicle entirely. This action is important as it resets the system and allows you to assess how the transmission responds when transitioning from motion to a completo stop. Pay attention to how well the transmission shifts during this deceleration, as it provides insight into the health of the control solenoid and the CVT's overall performance. This stage allows for a controlled environment to further examine the issue at hand and gather more data on the solenoid failure indications, creating a clearer picture of its performance under different loads. In this fourth step, you will need to accelerate from a complete stop, bringing the vehicle up to 37 miles per hour in the D position again. This test is vital as it assesses the solenoid's response from a standstill. While performing this step, monitor any slipping or hesitation during acceleration, which can indicate that the valve is not functioning correctly and remains in on position. Observing the vehicle's behavior under these conditions will help illustrate any abnormalities linked to the solenoid's performance. A successful acceleration without issues can help determine if the problem is consistent at different speeds and driving conditions. Finally, reduce the speed and come to a complete stop again to conclude the evaluation of the CVT system behavior. This step allows for a comprehensive assessment of the solenoid's condition through multiple cycles of acceleration and deceleration. Ensure that any issues previously noted persist in this phase, as consistency in symptoms can aid in confirming the diagnosis. Any irregularities observed during these speed transitions can reinforce the likelihood of the solenoid being stuck or malfunctioning. Completing this step not only finalizes the testing, but also gathers crucial feedback regarding the system's operational characteristics under real-world driving scenarios. Once the troubleshooting and any necessary repairs are complete, it is essential to perform a final verification of the repairs conducted concerning the DTC P0777. Operate the vehicle under normal conditions to ensure that the issues related to the solenoid valve are resolved and that the CVT operates smoothly without slipping or abnormal gear engagement. Monitoring the vehicle's performance over a range of various speeds and acceleration patterns is crucial for confirming functionality. If everything operates correctly without triggering the DTC, your repairs can be confirmed as successful. It is equally advisable to clear any stored trouble codes in the vehicle's system and conduct a test drive to confirm that the code does not reappear. To prevent future occurrences of DTC P0777, establishing a routine preventive maintenance schedule is important. Regular checks of the transmission fluid's quality and levels will help ensure that the CVT operates effectively without contamination that could hinder performance. Additionally, inspecting the electrical connections leading to the solenoid regularly can identify potential wiring issues before they escalate into more significant problems. Keeping the transmission filter clean and monitoring for wear and tear on the solenoid can also greatly extend the functional longevity of the CVT system. These practices contribute not only to the performance reliability of the transmission, but also preserve the overall integrity of the vehicle. In conclusion, Diagnosing and troubleshooting the DTC P0777 involves a deep understanding of the CVT system, specifically the driven pulley pressure control solenoid valve's role. Through careful observation of symptoms, systematic troubleshooting steps must be followed to accurately assess the issue at hand. Ensuring that the solenoid is functioning correctly is paramount for maintaining the health of the transmission system. Following these troubleshooting protocols not only aids in resolving immediate problems, but also helps to establish a foundation for preventive maintenance strategies that can avert future complications. Armed with this knowledge, technicians and vehicle owners can confidently address and mitigate issues relating to the continuously variable transmission in the Honda Civic. Please like and subscribe to the channel. See you next time.